It is not easy to define the term energy because there are so many different forms of energy: potential energy, kinetic energy, nuclear energy, chemical energy, electromagnetic energy, energy stored in chemical bonds of chemical compounds, electrical energy. Energy has many faces. So, how can we talk about something that is so important and so elusive? We need to narrow it down. In class, we will call energy the ability to produce change, an ability to produce heat. There are two big categories that are frequently discussed: potential energy and kinetic energy. Potential energy is the energy stored in the object due to its position or composition. Chemical compounds store energy inside of its chemical bonds. Composition of a compound depends on it. In this picture, Legolas pulled back the string in the bow. Currently, the string is not doing anything. It is just pulled back. But due to its outstretched position, currently it has a potential to make a change. When released, it will push the arrow. Kinetic energy is the energy of motion. You can think about it as energy in use. When the string was released, potential energy of the string was converted into kinetic energy of the moving arrow. All the potential energy of the string now is different form of energy, kinetic energy of the arrow, which is in its turn will be converted into another form of energy when it hits its target. So energy is never lost. It is just converted into a different form of energy. So here comes the law of conservation of energy. Energy cannot be created or destroyed. However, energy can be converted from one form to another, potential to kinetic, kinetic to heat, and so on and so forth. When we say that we are losing energy, we're just complaining that energy being converted or transferred into something that is not beneficial to us. Since we will talk extensively about heat and temperature, it is time to define those terms. Temperature is the measure of random motions of the components of a substance. These two boxes represent cold and hot air. The box on the right represents hot air. Those long lines show that particles in the air in the red box move very fast. The air in the box on the left has more particles, but that is not important. The shorter lines show that the particles in the blue box are moving slower than the particles in the red box, so the temperature of the air in this box is lower. Here is a model that will help us to visualize what happens to a substance when temperature is changed. In this container, I have a gas and particles of the gas are moving. They all have certain amount of kinetic energy. Temperature tells me how much of kinetic energy on average I have in the particles of my substance. The heat transferred into the container makes the particles to move faster. If particles are moving faster, there is more kinetic energy in them. The temperature is rising. The temperature is a measurement of the amount of kinetic energy in components of the substance. Now I will cool down my substance. Heat is transferred away from the container. The particles are moving slower. There is less kinetic energy in them. The temperature is decreasing. Temperature is not energy. It is not heat. It is a measure of average kinetic energy in the components of a substance. Temperature is not energy, but it is related to energy. Transfer of energy into or away from the substance changes the amount of motion, amount of kinetic energy in the substance, which will register as a change in temperature. Now that we understand temperature as the measure of the amount of kinetic energy in a substance, let's define heat. Heat is energy, or to be more specific, it is a flow of energy due to temperature difference. Here I have my hot and cold air again. The molecules of the hot air are moving fast. They will smash into the walls of the container, transferring some of their kinetic energy to the wall. The molecules of the hot air will slow down, and the temperature of that sample will decrease. The energy will be carried across the wall, and some of the particles of the colder air will pick it up on their contact with the wall. Getting additional energy will speed them up and the cold air will warm up. Heat always flows from the area where there is plenty of energy into the area where there is less of energy. If you touch snow with your hand, the heat will flow from your hand to the snow, melting it. If you touch something hot, the energy will travel from the hot object to your hand and may burn you. The object with the lower temperature has less energy. The object with the higher temperature has more energy. Energy always flows from the area where there is more energy into the area where there is less energy. Let's look at some practice questions. A 50-gram block of copper at 10 degrees Celsius is lowered into 100 grams of water at 90 degrees Celsius in an insulated container. Describe the transfer of heat in this system. Okay, so our block is at 10 degrees Celsius, relatively low amount of energy, while water is at 90 degrees Celsius has significantly more energy. So we expect water to be sharing the energy with the block. The flow of energy would be from the water into the block. Another problem. A 35 gram of aluminum cube at 100 degrees Celsius is placed in 90 grams of water at 25 degrees Celsius. Once again, we need to describe the transfer of heat in this system. Well, aluminum block is 100 degrees Celsius and water is only 25. Water has less energy than aluminum, so we expect the energy to flow from the aluminum into the water. And this last problem is for you to handle. Let me know what you think.